Hello everyone. Here in this video, we are talking about the apparent change in the frequency due to relative motion of observer, which is a concept of Doppler effect. So before going ahead, let me once define Doppler effect for you. Doppler effect is the apparent change in the frequency that happens. Be careful, you are writing as an apparent frequency. Frequency originally doesn't changes, but it appears like changing for you. Apparent change in the frequency due to relative motion of source and observer. Relative motion of source and observer. In the previous video, we have discussed about the motion of a source. Now we would like to talk what happens when the observer is in the state of motion and the source is in the state of rest. Let us have a look at that. What do you mean by that, right? Imagine a source who makes a sound is in the state of rest. Observer who hears the sound, who receives the sound is also in the state of rest. There is no relative motion in this case. So the sound goes like a wave with a certain frequency. What is the frequency that it is? N is equal to V by lambda, where V is the velocity of the sound, lambda is the wavelength of that wave. Now let us imagine a case, there is no Doppler effect in that case, but now imagine a case where the source is in the state of rest, but observer is not in the state of rest, but he is moving towards the source. So we are talking when observer is moving towards the source. So what happens is waves reach the observer due to the motion of the due to the velocity of a sound with a frequency n that is there anyway. But observer receives more waves as he is also crossing waves. Let me tell you what is the meaning of this. How do you how shall we perceive it? How shall we understand it? Let's imagine that you are on a highway standing in rest. There's a convoy of the vehicles, like an army convoy, who is going at regular intervals. They're all crossing you. You are counting how many are crossing per second or per minute, right? So per minute, say for example, you found that some 10 vehicles are crossing you. When you are in the state of rest, like this, you are here in the state of rest. Now you imagine a case that you are not in the state of rest. You have started moving in this way, like you are an observer, you are moving this way, right? What happens? These 10 vehicles anyway cross you, but as you are moving towards the vehicles, he will also cross some extra vehicles. So the total number of vehicles crossed when you are moving towards the vehicles is going to be greater than 10, isn't it? He will count more vehicles now per minute than the previous case. The same is going to happen. As you are moving, the original frequency anyway will experience, but he will receive an extra experience, and dash is equal to V observer by lambda. Extra, because you are also crossing it. So what is the total number of the waves that are crossed? Total frequency is how much in this case is original frequency plus extra frequency because of the motion of the observer towards the source. So the total frequency is n dash is n plus V observer by, in the place of lambda here I can write, here in the place of lambda you can write V by n. V by, in the place of lambda I can write V by n. So n plus V observer by V of n, where V is the velocity of the sound, Vy is the velocity of the observer. If I take n common, 1 plus VO by V or V plus VO by V of N is N dash. That's the apparent frequency experienced by a observer when he is moving towards the source. What you could have noticed here is, the numerator is V plus VO, where V is the velocity of observer, VO is more than the denominator V, velocity of the sound. So in this case, you can say N dash is obviously greater than that of N. That is when the observer is approaching the source. Let me explain the another case. The other case. What is that other case? Source is in the state of rest, but observer is moving away from the source. What happens now? The original velocity of the sound has a frequency n equal to v by lambda that will reach the observer anyway. But like the previous case, you are not moving towards the vehicles now, but rather you are running away. You are moving away. If you move away like this, not in the direction of the vehicles, but against the direction of the vehicles of the previous example, you are not allowing that regular 10 vehicles itself to cross you because you are running away from it. So the total number of the waves that you receive here is, when the observer is moving away from a source, is original waves minus waves that you are not allowing to move because you are moving away against the direction of their motion. That is extra n dash. Extra n dash is VO by lambda. Be careful. Here I have written plus because you are crossing more frequency, more waves while you are approaching the source. Here you are going away from the source, so you are not allowing the waves to cross you, so you will receive less number of the waves. That is VO by lambda minus. In the place of lambda, here I can write from here as V by N. So 1 minus VO by V of N. It implies N double dash equal to V minus VO by V of N. So if you notice carefully, your numerator is less, denominator is more. So what we can say is N double dash in this case is less than N. So when the observer is approaching the source, apparent frequency is more. When the observer is going away from the source, apparent frequency is less. So you can write a general format as V plus or minus VO by V of N is the equation for the apparent frequency of Doppler effect. Right? Plus has to be used when the observer is approaching. In this equation, minus has to be used when the observer is receding away from the source. In the next video, we will combine both the cases of motion of observer as well as the source, but we are not going to derive it in that case. We will use this videos for the next video. That's it. Thank you for watching.